Hello, my dear fellow, my dear beings, be it mineral, vegetable, animal, including Homo sapiens, aliens, and energetic entities. Okay. I am Ferruccio Bilic. I'm going to present now a paper called Knowledge Management for Sustainable Development. Okay. The objective of this paper, the purpose of this work is to analyze the scientific and technological productivity management of several countries and their impact on economic sustainable growth, including in Latin American countries. Difficult to get the point. Using multi-criteria analysis. In other words, how the knowledge management can contribute to development. Here we have the data of scientific productivity circa the year 2000 of several countries. Okay, is in the ranking. First in the ranking is Switzerland with 51.12 publication per resident, and second one, the rank is Italy with 47.74 publication per resident. This is a variable that we are going to use later, and we will explain in more detail later how to compute it. What's important is the ranking. The value we will explain later. The technological productivity also, circa the year 2000, is the first in the ranking is Germany, with a productivity of 83.37 patents per resident. Definitely is patent by per 10,000 residents, probably. We will see later. Switzerland, the second one in the ranking, and the Netherlands, the third one, and the United States in the fourth one in the ranking. Okay, the methodology that we employ in this work is the following. Science and technology data was collected for several economies, including Latin American countries. With this data, the scientific and technological productivity indicators were developed. Okay. Econometric analyses were performed relating the scientific and technological productivity to their science and technology producing factor, respectively. A further analysis related scientific and technological productivity to economic indicators. Okay? The dependent and the independent variables were related in the logarithms formulation. The linear in the logarithm formulation has proved relevant and useful over the years for a long series of empirical studies. This affords a pragmatic basis for its use here. Among its advantages can be listed the following. First one, it is easy to fit. Second, the individual terms possess economic significance. The coefficients of the independent variable are the elasticity. Third, its residual or error performed better than, for example, simple linear formulation. Because the use of logarithms will in theory stabilize the variance of the conditional distribution of the dependent variable given the independent variables. Okay? And this formulation is in perfect agreement with the Stevens law of psychophysics, the first law of psychophysics, given a solid theoretical basis for this formulation. Stevens' law of psychophysics says the following. The variable, dependent variable, perception is equal to stimulus S raised to the power alpha. And therefore, is a exponential formulation that it can be transformed into a linear in the logarithm formulation. Okay. Analysis of scientific productivity. The scientific productivity measure in terms of number of publications per R&D scientist or engineer. Publication per scientist or engineer can be related to science producing factors such as the number of scientists and engineers engaged in R&D. And the amount of expenditure per R&D scientist or engineer, X by SNE, in a linear the logarithm formulation. Linear in the logarithm formulation. Circa 2000, the scientific productivity is explained by expenditure in R&D per researcher, X given researcher in economic terms. Let L pub / res be Neperian logarithm of publication and science and technology per 1,000 researchers, circa 2000. For the number that we saw before was 51 publication per 1,000 research. LXP P res is the Neperian log or natural log of expenditure in R&D, research and development per 1,000 researchers circa 2000. The resulting econometric equation is LPUB is equal to 0.955 log of expenditure. This is the F value and this is the R2. This is the error. Analysis of technological productivity. The technological productivity measured in terms of the ratio of the total number of patents granted to residents of the country per total number of scientists and engineers engaged in R&D, PAT/RES, can be related to technology production factors such as number of scientists and engineers engaging in R&D. And the amount of expenditure per R&D scientist or engineer in the logarithm formulation. The technology productivity is explained by expenditure in R&D per researcher in economic terms. LPAT per researcher is the Neperian logarithm of patents granted per researcher circa 2000. This is the Neperian logarithm of expenditure in R&D per research circa 2000. The resulting econometric equation is patent in terms of expenditure, gives this coefficient. The F statistics, the R2 and the adjusted R2, R squared. Economic indicators and S&T productivity. The economic indicators are explained by S&T productivity in econometric terms. LGNI is the Neperian logarithm of gross national income of countries circa 2000. LPUB/RES, Neperian logarithm of scientific productivity of countries circa 2000. LPAT/RES, Neperian logarithm of technological productivity of countries circa 2000. It was run a multivariate regression with a dependent variable, LGNIE, and the possible explanatory variables, employing a stepwise method. The result econometric equation is LGNIE is equal to 1.767 L of publication per researcher. Adjusted R square is 0.859. Similarly, the GNI, gross national income versus science and technology productivity for non-Latin American countries. Okay, here this same kind of variable, And the resulting equation for non-Latin American countries is LGNIE equal 1.843 L pub per research. The adjusted R2 square is 0.883. Latin American country GNI versus S&T productivity. Okay, here again we have the same kind of definition for the variable, and it was from the multivariate regression with the dependent variable LGNI and the possible explanatory variable. This for Latin American countries. And the result was LGNI is equal to 1.731 L pub per research, publication per research. And the adjusted R square is 0.827. Now we are going to have Latin American countries' technological versus scientific productivity. The technological productivity of Latin American countries can be explained by scientific productivity in econometric terms. These are the definition of the variable, all for Latin American countries, and the resulting econometric equation is L patent per researcher is 0.88 publication per researcher. Okay. Non-Latin American countries technological versus scientific productivity. Similarly, for non-Latin American countries, we have the following result. Is LPAT per researcher is 0.809 L publication per researcher. Non-Latin American technological productivity versus expenditure in R&D. Okay, these are the variables, the description, and these are the result, the resulting econometric equation. L is the parent log of patent per researcher is equal to 1.265 log of expenditure per researcher. Now we have Latin American countries, technological productivity versus expenditure in R&D. Similarly, for Latin American countries, we have logarithm, the parent logarithm of patent per researcher is equal to 0.588 logarithm of expenditure per researcher. Now we are going to discuss some knowledge economics. Circa 1980, the economic indicator are explained by S&T productivity in econometric terms. Here we have the perennial logarithm of gross national income for all countries circa 1980. Here we have the perennial logarithm of technological productivity of all countries circa 1980. And we have here the perennial logarithm of scientific productivity of all countries circa 1980. And running their multivariate regression, the result is with the stepwise method. The period logarithm of gross national income is equal to 0.701 log of patent per research. Logarithm of patent per research. Knowledge Economics circa 2000. Similarly, we have a economic equation for around the year 2000, circa 2000, and the logarithm of gross national income is equal to 1.767 log of publication per research. Okay. Now we are going to make an analysis of using multi-criteria methods. The criteria employed in this analysis, the criteria were maximize gross national income, maximize publication per research, maximize patent per research, and minimize expenditure per research. It was considered that all the criteria were equally important, therefore they received the same weight. The Prometheus multi-criteria method was employed, and here we have the ranking of countries according to multi-criteria, to these multi-criteria that we just described. They are in alphabetical order. Here is the phi plus and the phi minus, and the phi net is this one, and the ranking is this one. Okay, and we can see that Argentina is the 26th in the ranking. Bolivia is the 36th in the ranking. Brazil is the 20th in the ranking. Canada is the 18th. Cuba is Colombia is the 32nd. Cuba is the 24th. Chile was the 11th. US was the 6th. And so on and so forth. Okay? Continuing with the countries in alphabetic order, and here we have the respective ranking. Netherlands, the 4th ranking. Italy, the 5th. Now the 3rd. France is the 5th. Norway is 16th. Sweden is the 3rd. United Kingdom is the 2nd. And here, Switzerland is the 1st, and so on and so forth. Here we have the Gaia plans, all the results, all the countries plotted in the Gaia planes, okay? As we saw, Switzerland is the first one, highest. These are the several axes of expenditure, axis of publication, and so on and so forth. Okay, and with the first, second, third, so on and so forth. Okay. Conclusion. It was verified that as the country valorizes more its R&D scientists and engineers through investing more in R&D, greater would be the scientific productivity, mainly in knowledge management. The Latin American countries, among all the countries in the world, will have the highest response in terms of scientific productivity to increases of investment in R&D, measured in terms of expenditure per R&D scientist or engineer. In conclusion, it can be said that all the R&D scientists and engineers of the world will produce more, write more, and publish more if they are better paid and have better equipment for doing research and apply in knowledge management. This is particularly true for R&D scientists and engineers of Latin American countries that will have the highest response in scientific productivity to increases in expenditure per R&D scientist and engineer. With respect to which of the productivity is more relevant for producing increase in the gross national domestic product of the country, it was verified empirically through econometric analysis that circa 1980s the technological productivity was more relevant, while circa 2000 the scientific productivity had become more relevant. This confirms empirically the notion that the countries of the world were moving towards a knowledge-based economy that is broader than more sophisticated and dynamic than a mere technology-based economy or society. Okay? Therefore, we are moving towards a more knowledge-based society instead of just a knowledge-based economy. According to the multi-criteria analysis performed, the criteria maximized implying higher development, maximization path per research implies technology productivity, the maximization of publication implies scientific productivity, and minimization implying minimizing expenditure per scientist. Switzerland came up first in the ranking criteria. The work would develop here support a new reliable tool for analysis that allows decision makers to reach a consensus to sustainable development. Okay. Here I would like to point out that I would appreciate if you put your like in this presentation, this video. Also, I would appreciate all your critique and comments and suggestions. And you can share this with whoever you want. And if you are not subscribed yet, you can make your subscription in my channel. Doesn't cost a penny, and it will be very appreciated. Thank you for your attention.